welcome again to Drs. Howarth and Ingraffia. Very timely topic here for our planet, how we move forward and how we do this, and some of the research and data that's prompting all of us to be fully aware. Thank you very much for giving of your time and sharing with this group.
Okay, well, it's great to be with you today, this morning, this evening, wherever you are. Tony and I will do a little teamwork here. I'm going to start first talking about the urgency of global warming, and then we'll cover some other related topics and get on to clean energy as we move along.
Great. Just so you know, Dr. Howarth, we are seeing your presenter image. So we see your little side note or the next upcoming slide.
Is that right?
Which is actually wonderful because it lets us tune into all elements. If that's okay with you, it's wonderful for us.
Fine. Okay, you're seeing the entirety of the big slide though, are you?
Yes. Yep.
Okay. So we wanted to start with the urgency of global warming, climate disruption, as Renee described it. And I want to assure you that the climate scientists really understand quite well what's happened to date. There's 100% consensus among climate scientists that the climate is warming, it's leading to climate disruption, and that humans are the cause of that. Almost entirely greenhouse gas emissions and mostly from fossil fuels. So in this figure, we're looking at the rate of atmospheric warming over the 20th century and early part of this century. And what I want you to notice is the blue line there, no human influence. There are aspects of the climate which cause the Earth to warm at times and cool at other times. The intensity of sunlight changes over time, the tilt of the Earth changes, and those things are important in the temperature. So the line that says no human influence is a model projection of what the climate would have been had it not been for human release of greenhouse gases. You can also see notable cooling periods there. Those are after volcanic eruptions, which throw a lot of dust high into the atmosphere and cut down on sunlight reaching the Earth for a while. The actual rate of warming is the measured line there, the dotted line, which you can compare with what's modeled from human influence. And the difference between the no human effects and that is simply the increase in greenhouse gas emissions. And until about 1960 or so, the greenhouse gas emissions were small enough not to make a huge difference. But increasingly since then, both carbon dioxide and methane have increased and had a dramatic influence on the climate. If we look going forward, I'm showing you here again the Earth's atmospheric temperature from 1900 up to 2011. That's the dotted line. And we're looking at some projections. This is from a paper published in 2012. We're looking at some projections of what the future climate might be. And I'll come back and talk a little bit more about this in a moment. But for the moment, just take a look at the top line there that's labeled reference. That is the model projection of what the Earth's temperature would be had we made no effort to reduce our emissions of carbon dioxide and methane, which of course we have not. And you can see that we would hit a temperature of about 1.5 degrees above the pre-industrial baseline in the time period of about 10 years from now, and 2 degrees Celsius above the pre-industrial baseline in the time period of perhaps 25 years from now, something like that. In fact, if you look at those red dots, those are the actual temperature warming, and you can see that the Earth's warming a little bit faster than this model predicted back in 2012, and that's because we've actually been putting out more greenhouse gas emissions, both carbon dioxide and methane, than predicted. So why am I highlighting 1.5 and 2 degrees Celsius? 4 years ago, this month, the nations of the world came together in Paris for the United Nations COP21 agreement, and for the first time ever agreed that it was critical to slow the rate of global warming. And they said, you know, a warming of 1.5 degrees is dangerous. 2 is really dangerous. So 1.5 is going to be a tough target to reach, but we really need to keep the planet well below 2 degrees Celsius. And that's a commitment. So far, not enough has happened to reach that, but it's a realization that that should be the goal. Why is the goal? Well, we, of course, are seeing climate warming. We are seeing climate disruption. People are getting hurt from that. But the real worry is that things could get worse, and they could get worse in a way which would be irreversible on the time scale of, say, the next 10,000 years or more. So we call these tipping points in the climate system. And I won't go through the detail of all of these, but this is a presentation pulled together by the Intergovernmental Panel on Climate Change, so a group of international scientists working with the United Nations back in 2007. And there are a variety of things which could go awry in the climate. So they're looking at different examples of this. And this was their best thought as of 12 years ago as to the likelihood. Bottom line is, if the temperature stays in the white range there, the scientists are saying we probably don't need to worry about this tipping point. But as you warm to the yellow, the risk becomes greater, and as you warm to the red, it becomes quite high. And again, many of these things cause changes in the climate which are truly irreversible. So I'm going to mention the one furthest on the right, which as of 12 years ago, most scientists were saying we didn't need to worry about until we warmed the planet until 3 to 4 degrees. Unfortunately, that's wrong. And what we're seeing is that this tipping point is already occurring. So what's the tipping point here? It's a change in the ocean circulation pattern. I'll go to the next slide to walk you through it a little bit more. We started to see signs perhaps 5, 6, 7 years ago that we're hitting this tipping point, but it's now quite clear that we are. Fundamentally, what's happening is, as we've melted the Arctic ice, and as we've melted the ice on Greenland, we've added a lot more fresh water to the Arctic Ocean and to the North Atlantic Ocean. Ocean's still salty, but it's not as salty. And since it's not as salty, it's not as dense. So that makes a big difference in the ocean circulation as a whole. The North Atlantic is the coldest, densest water on Earth. That means it sinks. It slowly moves in deep water to the Indian Ocean and Pacific Ocean on the timescales of 400 to 1,000 years or so. And then warm ocean water comes back from the Indian Ocean, the Pacific Ocean into the North Atlantic. That affects the climate globally in remarkable ways. It also is important for carbon dioxide, because about 25% of the carbon dioxide that's emitted from our burning fossil fuels is taken up by the ocean and stored for hundreds of years, 1,000 years, due to the sinking of water. So as we've made the ocean a little bit less salty in the North Atlantic, we've slowed that circulation, and the likelihood, if that continues for another decade, is that we'll accelerate global warming because the ocean's taking up less carbon dioxide. We'll have to cut back our emissions from fossil fuels even more than we thought. And fundamentally, that's unlikely to reverse itself for at least another 5 to 10,000 years. So to Tony.
Yeah, let me add my thank you for joining with us today. We really appreciate this international convening of students so that we have a chance to discuss the issues at hand. As my colleague Bob Howarth had just pointed out, the issue about climate change is really the issue of emissions, human-induced emissions from the use of fossil fuels, not just the burning, but the obtaining of those fossil fuels. And so I want to just point out at this point just one slide, so we can go to the next one. In about 1/2 of my lifetime, half of all of the emissions that have occurred from the use of fossil fuels have happened. So this slide, which on the horizontal axis shows year, and on the vertical axis essentially shows the consumption of the various sources of energy. You will notice that the use of the fossil fuels, coal, oil, natural gas, have increased tremendously. And their use is not decreasing on a global scale. That showed up in the chart that Professor Howarth showed you a few minutes ago, which shows that the projections of business as usual, the reference case, predicts that we would be at 1.5 degrees within this next decade, at 2 degrees, perhaps 2 decades from now. And that reference case assumed that the rate at which we were using fossil fuels would remain the same, but in fact, the use of fossil fuels continues to increase. Most notably here, if you look at the yellow, which is natural gas, that's the one that's increasing the most. And unfortunately, the thing about natural gas, which is mostly methane, is that it's a double-edged sword. When you burn it, it produces carbon dioxide, just like oil and just like coal. But if you produce it and you don't burn it and it gets into the atmosphere, it's a very potent greenhouse gas. And for the first time in our presentation to you today, certainly not the last time, we're going to note that methane is a much more potent greenhouse gas in its ability to trap heat in the atmosphere than CO2. And it's really the only dial, rheostat switch that we can turn in the short term that can have substantial influence on decreasing the rate of global warming. So 2 things I want you to take away from this slide. The use of fossil fuels has been awesome in the last 28 years. Half of all the emissions have occurred in that 28-year period. The rate at which we're using fossil fuels has not been decreasing despite everything we've learned about climate change, despite the agreement in Paris almost 5 years ago now. We have to turn that around. And we're going to show you as the slides go on and as we have discussion with you, that the ability to turn that around has been in our hands for a long time. And we're going to show you how, depending upon what country you're coming from, how you could do it. So let's go to the next slide, Bob.
Next slide. I want to talk a little bit more about why natural gas is not a good idea. And again, Tony has told you that natural gas is mostly methane gas. Methane is the second most important greenhouse gas after carbon dioxide. And for the time it's in the atmosphere, it's more than 100 times more potent than carbon dioxide. So small emissions of unburned methane to the atmosphere are really very damaging. Now, if we go back about a decade to 15 years ago, the oil and gas industry and some others started to promote this idea that natural gas perhaps could be a good bridge fuel. And the idea, you don't want to believe this, but the idea that was put forward is that we aren't yet ready for using renewable energy, solar and wind. That will come eventually. We still need to use fossil fuels to power our economies and our economic growth. But perhaps we should move away from coal and towards natural gas for this bridge of a few decades. And the logic behind it's shown in this slide. And it's, if you look at how much carbon dioxide is emitted to get a unit of energy, coal is a bigger carbon dioxide polluter than is natural gas. So that's the logic of the bridge fuel. The problem again is that natural gas is methane, and when we use it, some of it's emitted, and it doesn't take much of that emission, either leaks or just purposeful emission due to the technologies, to counteract any advantage that might occur from producing less carbon dioxide. So here on the right, I'm showing you a slide that represents the greenhouse gas footprint of coal, diesel oil, and natural gas. And the yellow-orange color there are the carbon dioxide emissions to get a particular amount of energy. So yes, there's less carbon dioxide from natural gas, but the red is our best estimate of what methane emissions associated with using and producing the fuel might be converted to carbon dioxide equivalencies. And there's some methane emitted with using all fossil fuels, but it's a bigger problem with natural gas because, again, natural gas is mostly methane. So it's really not good for the climate at all, at least on the short time period. And one other aspect of that, going back to the slide that I introduced you to just a few minutes ago, we talked about the reference line there, the prediction of what climate would look like if we didn't reduce emissions of carbon dioxide or methane. The next line down below that, labeled CO2 measures, carbon dioxide measures, is what would have happened to the Earth's climate if we had aggressively started reducing carbon dioxide emissions back in 2012, but not done anything else. And you can see that it really has no influence on the rate of global warming for a period of 20, 25, 30 years. Eventually, the climate responds. But the climate responds very slowly to changes in carbon dioxide, and that's because it's being taken up and released again by the oceans and taken up and released by forests. There's this big buffering influence. So if we were to simply focus on carbon dioxide, we would blow right through that 2 degrees Celsius temperature, which we know is quite damaging to the climate, and blow through all sorts of tipping points. We just don't want to do that. So the bottom 2 lines in this projection are predictions of what would happen if we also looked at reducing methane emissions, either alone or with carbon dioxide. And the bottom line is that the climate responds much more quickly to changes in methane emissions. If we reduce methane's emissions, if we had started to reduce them back in 2012, the climate would have started not warming as quickly right away. It would have slowed the rate of global warming, and it really gives us a potential to meet that COP21 target of keeping well below 2 degrees Celsius. It's the only way. Tony has told you this. It's the one dial under human control that we have, which can immediately slow the rate of global warming while we also address the problem with carbon dioxide.
Okay, so now you know what the problem is. Global warming, climate change, climate disruption. Hopefully we've informed you about something you already know. We've just deepened your understanding of the cause of the problem, and that's human induced. It's the use of fossil fuels. So what do we do about it? And you already know the answer to that. Again, we're just going to provide you with backup and more deeply, hopefully a more deeper understanding of what can be done. And that's to switch on a global scale, to transition from a fossil fuel based energy economy to a renewable energy economy based, in our opinion, only on wind, solar, or hydro. Notice we're not saying anything about nuclear. We're not saying anything large about biomass. We're saying wind, solar, and hydro. So in the next couple slides, go ahead. I'm going to point out that a large group of scientists and engineers have focused specifically on roadmaps for first every state in the United States, and then for almost every country on the face of the earth. And this is an effort that's led by Professor Mark Jacobson, a civil engineer at Stanford University. And he's had input from a wide variety of scientists and engineers in the US and elsewhere. And over the last 5 years, they've developed roadmaps for, like I said, in this case, every country. We're an international audience today. So for example, you can go online. The website is at the bottom of this slide. And for those of you in France, if you want to know what would a most reasonable approach be to manage the decline of the use of fossil fuels in France while managing the increase in the use of renewable energy, this is the roadmap. And it says by 2050, if France were to start using wind, solar, and hydro in the proportions shown in this chart, offshore wind, onshore wind, commercial and residential solar, large-scale solar, hydro, wave. There are all kinds of ways of generating renewable energy from those 3 sources. Every country is going to have a different mix in its roadmap. And so this is the roadmap for France. Let's go to the next slide. This is the roadmap for Bangladesh. And you're going to have some time later to compare these roadmaps. You'll get access to all the slides we're showing you. And you can see there are substantial differences between France and Bangladesh, as you'd expect. Sunlight is more intense in Bangladesh than it is in France. France has plenty of opportunity for both onshore and offshore wind. So again, this is particularized for Bangladesh. It's different than the one for France. It's going to be different than the ones I'm going to show you next. But on each of these slides, in addition to showing you the components of the recommended wind, solar, and hydro sources, we also note something about the economics of this transition. I mentioned that it has to be a managed transition. And that management has to come from the highest levels of our country's governments. In each case, we point out the number of new jobs as one metric of economic impact that would accrue if the country in particular were to adopt this particular roadmap. And in each case, we point out the jobs that are temporary while the transition is occurring and the jobs that are permanent, new jobs being created because of the new sources of energy. Go to the next slide. We're going to skip this one because unfortunately Croatia had technical problems today. They couldn't join us. But let's visit the United Kingdom. For those of you who are in England, here is the roadmap. Again, it's different than the roadmap we showed you for France and for Bangladesh. It's different in the number of jobs being created, but in each case, the number of jobs is tremendous, and it's just one indicator of economic impact. Let's go to the next slide. Texas. Texas is well on its way to wind and solar. Not too much hydro available in Texas, as you can see from this roadmap, or you will see when you look at it in detail. But you know, Texas leads the nation in wind energy creation, and it's going to continue to grow. You have a tremendous resource there. You're lagging behind in solar compared to states like California, even though you have more solar than just about any other state in the continental United States. So Texas is doing well. And again, the tremendous number of jobs available as an indicator of economic impact. So I hope you have an opportunity, each of you, to take a look at these deep roadmaps in particular. Let me go to the last one, which is New York. So Professor Howarth and I are sitting here in New York State. We were part of the group that first formed the organization that put these calculations together. So we're very happy that this has been expanded beyond the states in New York, and it now includes countries all around the world. But I wanted to show you this slide because if we hit it one more time, there are other economic impacts, not just jobs. As we reduce the use of fossil fuels, we reduce pollution. As we reduce pollution, we reduce death and illness caused by pollution. And there is a real cost associated with decreasing morbidity and mortality. And this slide, for example, shows that we could recover the entire cost of transitioning the state of New York to wind, hydro, and solar merely by decreasing the cost, the health cost that is associated with the use of fossil fuels. There's another cost involved, and obviously we're talking about climate change. It's the cost of climate change itself. Disruptions, mass migrations, floods, desertification, sea level rise, all of those have real costs. And as each state and each country contributes to decreasing the use of fossil fuels, we lower those costs. So this is not just our talking about the climate science, not just talking about the drilling and fracking science. There's social science issues that are very important here. You students that we're talking to, you're not all going to become scientists and engineers. Many of you will become economists. Many of you will become sociologists. Some of you will become doctors. So you're all going to be impacted by this massive transition that we're in the middle of right now in going away from fossil fuels. Bob, take it away.
Thank you. As Tony says, we need to move away from fossil fuels. We believe strongly that we can power the world. We can power each of our states and countries with solar, wind, and hydro. But the question comes up regularly, well, what about nuclear power? Do you need baseline power that comes from nuclear? And the answer is no. And we want to make sure that you understand this. Nuclear power, as it says here, is at best a distraction, which slows down our moving to renewables. It's very expensive. It's 5 times more costly than using onshore wind. And nuclear power is not getting any cheaper over time. If anything, it's getting more expensive, whereas wind and solar are becoming less expensive day by day and year by year. Nuclear is slow to deploy. It takes 10 to 20 years from the time you first start planning a project until it actually goes into operation. Wind and hydro and solar can respond much faster than that. And hydro is not free of carbon dioxide emissions. When you build the concrete shells and all of the processing for the fuel, there's significant carbon dioxide emissions, about 25 times more so than for wind. On top of that, there really is not a good solution for nuclear waste. It'll stay with us for millions of years. And on top of that, people like to say, well, a peaceful use of atomic power is good, but of course, nuclear weapons are horrifying. And if the easiest way to rid the world of the potential for nuclear weapons is to also get rid of the peaceful use of nuclear. On top of that, we've seen some huge tragedies, most recently in Fukushima in Japan. This is a dangerous technology. It's expensive, and it simply is not needed. We should move as quickly as we can to the true future, which is renewables.
Last slide I want to talk to you about. Go ahead and put it up, Bob. So we know what the problem is. We know what's causing the problem. We know what the solution to the problem is. How fast do we have to act? How much time do we have? Well, Bob has showed you the same slide 2 or 3 times now, which says if we don't act to reduce both carbon dioxide and methane, we've only got about 10 years before we're going to hit that 1.5 degrees, most likely a lot sooner than that. We've only got maybe 20 years before we're at 2 degrees centigrade. So we know we have to act faster than 10 years, have to act faster than 20 years. How do we organize ourselves to manage this very rapid decline? So I'm just going to show you a slide, which is an example. This is from New York State. These are calculations that we've done that show in an organizational way how each of the 5 sectors, we talk about the sectors of energy use. Transportation is a sector. Residential use is a sector. Commercial use is a sector. Industrial use is a sector. And power generation is a sector. Each of those has to experience a decline in the use of fossil fuels, which means a decline, rapid decline, in the emissions associated with use of fossil fuels in each of those sectors. So this slide merely shows over a time period of 1990 out to 2050, how quickly the emissions in each of those sectors would have to happen in our state in order to get to a point where, according to the calculations done with climate science, that we're at the point where we are in control of climate change. That's the idea that by 2050, 85% of our emissions have to be gone. Think of that. That's not very far from now. But if you were to study this chart in depth, you will notice that certain things are going to happen faster than other things because their effect is larger. You work on the low-hanging fruit first. You work on the sectors where, rather than having a decrease over the last 20 years, there's been an increase. And that's true worldwide. We've seen an increase in emissions coming from the transportation sector. There are a lot more cars, a lot more airplanes, a lot more trucks, a lot more ships emitting fossil fuel emissions now than there were 25 or 30 years ago. And in residential use, we have many more homes that are being heated with natural gas than we've had before. We're cooking with natural gas. We're heating our hot water with natural gas. That has to decrease very, very rapidly. So this is just an example of how you and each of your countries can work with your stakeholders to create a plan to do everything that Bob and I have just talked about. Stop the problem. Stop the problem at its source. The solution to the problem is at hand. The technology exists. We just need the will to execute. Bob.
Is this the last slide, is it?
Yep.
That's yours still.
Yeah. No,
that's it, huh?
Yep.
We're done then, I think.
Yes.
Renee, we are done.
We look forward to questions. We might have answers.
Thank you both very much. It's always inspirational at a certain level, dauntingly fearful at another level, but also informative, which is certainly what we need. The intent now is that I will moderate a round robin question and answer session from the various sites. So we will start kind of in the order that I did the roll call. We'll go to Woodford County and England first. So if you folks would unmute your microphone and ask any questions of the professors, that would be wonderful.
On a school level and on an individual level, how can we implement strategies to help combat climate change?
Go for it.
Well, you know, the technologies are there, right? What we need to do is to convince people that the technologies are there and that there's a pathway forward. And of course, there's the technologies were not here at a affordable scale, say 15, 20 years ago. So it's only in the last 5 to 10 years that the ability to make these highly efficient wind turbines and the highly effective solar panels have come in. We haven't talked a lot about other aspects of it, but you know, for heating, one should be using high efficiency heat pumps instead of direct consumption of fossil fuels in one's building spaces. And those have only been around again for another decade or so. So the technologies are there. A lot of people just don't understand how the technologies have developed to the modern state we're at. And of course, there's a lot of deliberate misinformation too. There are people who profit just fine from the status quo and would add to confusion. So I think a large part is the educational component, convincing your friends, your family, your friends' families, your society that yes, we can do this. I think that would be the number one goal.
Yeah. Let me just add to what Bob just said. You asked two-part question. What can you do as individuals? Well, Bob already indicated what you can do. When you're talking to your parents about what's the next car you're going to buy, or should you transform your home heating from a heat pump to a heat pump from burning oil or coal or natural gas? How are you going to heat your hot water? How are you going to cook the food in your kitchen? Those are all individual decisions that you can help your family make because you're informed. From the point of view of what your school can do, it's very simple. Listen to Greta.
That's funny. I'm recalling before we got into the official session, Dr. Ingraffia was sharing with me that, was it your daughter-in-law? Your daughter-in-law?
Yes.
Your daughter-in-law had called to say that she had changed from a Range Rover to an electric car because she had listened to Greta.
Yeah, and I'm sorry that was big Range Rovers are made in England and imported to the U.S. And she's driving this gigantic 2.5-ton Range Rover. And she listened to Greta. She felt guilty, and at great economic cost to her, she turned in the Range Rover and bought an electric car.
Yeah, so it's that sort of change. We know that the only energy we can consume that can be produced from renewable sources is electricity. So how do we go about making that transition? We're going to go next to the United States and Texas. So if you folks could unmute your microphone and engage, that would be fantastic.
Yeah, I have a question about the prices of all the green energy. Where would we get the money from? Would it come from taxes or would
We have a technical problem here, which is that someone has decided to do construction nearby my office. And there's a
buzz.
a loud drilling noise. I don't know if you're hearing it or not, but we can't hear over it. So I've asked someone from my lab group to go and see if we can get them to be quiet for a bit. But in the meanwhile, we couldn't hear your question. I apologize for that. Can you say it again?
Wanted to know about the cost to go to green energy. Would the cost come from individuals or it come from tax money, or how could we incentivize it to make it worthwhile to get going right away?
Yeah, I mean, that's a great question. And the costs are you know, they're non-trivial. Let's put it this way. On the other hand, they are affordable when you view it as the alternative. As Tony mentioned, the costs, fossil fuels not only promote climate change, they're polluting the atmosphere now in a way which is deleterious to our health. They make us sick, they prematurely cause death, and that's expensive. So the the amount of funds we're talking about to transition our societies is no larger than what we're paying already in terms of the damages from using fossil fuels. But of course, it's a different transfer of money. Different people are spending the money, if you will. Exactly how we make those work, it's probably going to vary country by country. It might vary state by state. Certainly, market forces are working to start to make the transition. So in most of the United States, it is cheaper now to generate new electricity from wind or solar than it is to build yet one more fossil fuel plant, right? Doesn't mean we still aren't building them, but the market forces are already telling us that must be stopping. We probably need to move faster than what a free market's going to do. So we need government incentives, perhaps. One widely discussed idea is a carbon fee, so that we, when we burn fossil fuels, we are charging someone a fee for the methane and carbon dioxide that's emitted associated with that. And the details of how that might work is highly debated. It was one of the things which they were debating in Madrid last week in the COP25, which unfortunately didn't really reach consensus. But one thought that I like is that we have a carbon fee that starts at a fairly modest amount, but over 5 to 10 years expands quickly to a substantial amount of money. So you can anticipate what that does as an individual or as a company, and that we take some of those funds and return them to the residents or citizens of the country or state. Obviously, the economically disadvantaged are going to be hit harder by a carbon fee than are the affluent people, although they're also the ones who are most hurt by air pollution and by climate change. So we need to, if we institute a carbon fee, we need to do so in a way that's fair and equitable. But that would be a way to increase the market pressure and speed the transition.
I'm going to say roughly the same thing Bob just said, but I'll give you an example of a different way of thinking about it. Here's the government, here's industry, and here are you. You're a consumer. So there are three reservoirs of money. The government has money, companies have money, and you have money. The government takes money from you from taxes. The industry takes money from you because you buy their products and services. So you, the individual consumer, are the source of where the money goes. What Bob has said, what I'm going to say in a different way, is we have to redirect the flow. We just have to redirect the flow so that the industry can't keep, the fossil fuel industry can't keep taking from you, making huge profits, continuing to invest in their fossil fuel development and paying their shareholders, because they're the people who are causing the problem. Okay, so you tax them. That's fewer taxes you're going to pay to get the same result, which is the transition. Okay, the government should be taxing them too. In the US, we have this problem where corporations don't pay as much taxes as poor people on a percentage basis. So there's redirection of this money flow. Think of it that way. But to always think of, you're the main source of where the money comes from in a stable economy. You don't want to just print money just to have more money. That destabilizes your country. Hope that helps clarify the idea here.
Texas, is that a good response to your query? All right, I'm going to go with yes. It made a lot of sense to me.
Thank you.
Thank you.
B plus, maybe A minus.
Yeah, basically what I take from it is, if we, and we have to do this in my community, we have to pay to dispose of our garbage. We have to pay for that privilege of somebody taking this away.
Yes.
Pay for that damage, if you will, that we do in that way. So let's do that with the garbage that we consume in terms of fossil fuels. We're going to turn next to Bangladesh. Bangladesh, if you could unmute your microphone and engage with the professors with your question, that would be fantastic. And then we will wind up going to France next.
Thank you very much for giving me the chance. First of all, I'd like to apologize a bit because my speech I think is a bit long compared to the others. So I'd like to say that, first of all, I'd like to say ours is a developing country, and like many others, Bangladesh is a bit poor, as a poor country. People of our country mostly live in the rural areas, and they are not very much, they are ignorant about climate change. And you know that clean energy it is expensive and costly to produce, and it's also costly to distribute. So in the context of our country, which is, the government has already taken some steps to establish solar panels and biogas plants. So we are working, but it is, as I said, it is costly to produce clean energy. So how can we reduce the cost of the clean energy and produce it in such a way that most of the people can use it and it won't take as much as money, so that they can use easily. The main point of my saying was, how can we reduce the cost to produce clean energy?
Did you get most of that?
We're having a hard time with the acoustics here.
Yeah. Renee, did you get most of that?
I believe I did. Let me see if I can rephrase for our young colleague from Bangladesh. The concern is the cost of the renewable energy.
Yeah, we got that part.
And how that can be reduced so in a country like Bangladesh, it is more affordable across all of the population.
Mm-hmm.
Did I get that accurate?
Yes, sir, you did.
Okay, that's
Fundamentally important question.
absolutely fundamentally. The cost, particularly of solar for Bangladesh, are coming down. I mean, solar costs are now about 10% of what they were a decade ago on world markets. They continue to come down. That doesn't mean that the most impoverished people can afford them yet. It's still a significant expense, but it is coming down, and it's going to take intervention by government or governments probably to help everyone out. But it is now, and it's becoming even more so, a less expensive form of electricity than would be generated from fossil fuels. So think of it that way. The particulars of how one would make it work in Bangladesh, I'm not really sure. And it's smart people need to pay close attention to what will work best for you. But you can be assured that the overall costs are coming down and will continue to come down for quite some time to come, probably.
Yeah, solar is, when you look at the roadmap, when you get a chance to look at the roadmap that was put together for Bangladesh, you'll see that solar was a major contributor to the transition, but so was wind. Wind is a much more capital intensive investment. And so there has to be an incentive for corporations, multinational corporations. And by the way, the number of multinational corporations engaged in wind keeps increasing because they see a huge market. They have to be incentivized to go to places that right now they're maybe not thinking of. Maybe they're thinking right now, France, Great Britain, great offshore potential and capabilities. When are they coming to Bangladesh? So part of the Paris Agreement was to help those countries, entice, actually force, try to force those countries who have the capital to invest in countries like yours where capital investment is too small at this point to approach wind in a big way. I would hope that the countries who agreed to provide that kind of funding would follow up. I know there's a question about whether the US is going to follow up on its commitments, but don't worry, we have an election next year and we hope that things will change.
We're working on it.
Yeah, we're working on it. So yeah, I'm hoping that underdeveloped, industrially undeveloped countries like Bangladesh that are at greater risk than a lot of other countries because of sea level rise would see the financial aid coming from places where it's been promised.
Thank you, sir.
What wonderful question. Thank you for that. I would also point out, and this is part of my motivation for doing these sessions, that you folks, the students here involved in these sessions, your minds, your bodies, yourselves will be more impacted over your lifetimes than what remains of my lifetime. So there is great motivation to have you engage in helping to solve this global crisis that we face. We're going to try to get through hopefully maybe another round, but first we need to stop over in France. So if we could have the folks from France unmute your microphones, it is up to you. France, we are not able to hear you. Let me see if I have done something. Oh, hang on a second. There we go.
Speaking. Right, can you hear me?
Yes.
Can you hear me?
Yes.
You have to speak louder. Okay, speak louder. Sure.
Okay. Which is the most effective way, in your opinion, to raise awareness about the issue of global warming? And which is the #1 obstacle, in your opinion?
I got the first part. What was the second one?
Well, the first part is what's the most effective way to raise awareness of global warming? I wish I had a good answer to that. You know, I've been a university professor since 1985. I was hired originally to talk and teach about global change back in 1985. If I was really very effective at telling people about it, you'd hope that we'd be further along than we are. The problem has more than doubled in intensity since I've started teaching about it. So I don't honestly know, but obviously global awareness is high now. I think the average person in the world realizes the climate is changing. I'm not sure they realize exactly how disruptive it may become. I don't think people understand the concept of tipping points and the fact that once we pass those, once you pass that threshold, there's no going back on the time scale of human society. I don't think people realize that. And so perhaps trying to get that message out. It's people, though they understand it's happening, they don't understand the urgency of dealing with it now. And I think often human society waits until something is really terrible and obviously in our face and then try to respond. In the case of climate change, climate disruption, we can't afford to do that. We need to be moving faster. So I guess, again, messaging that to one's friends, one's families, to your society around you is perhaps the most important thing. And we didn't quite catch the second part of your question.
What's about in your opinion, the #1 obstacle to the solution? Is it economic? Is it?
Well, I think the #1 obstacle is linked to the first part of your question. We haven't convinced enough people who vote and pay taxes to increase the pace of change. And until we get, certainly I'm speaking for the US right now, and for a couple of other large countries like Brazil, India, Soviet Union, or Russia, until we get those countries' leadership in line with the human solution to this human threatened problem, we're sort of treading water. So I'm hoping that the political situation in those large countries changes soon. I'd hate to think that it's going to change as a result of disaster. I'd like to think it's going to change because of the people who, in at least most of those countries, vote people into power. But I'm going to add to what Bob said about the first part of your question. We've talked today about the time frame in which change has to happen. And in previous generations, we relied on the slow, methodical process of education in schools, people reading books. Forget that. We only have a few years to make a very substantial turnaround and a decade to have accomplished something very substantial. So the good news is that news travels fast nowadays. Not only does it travel fast in the traditional media, TV, print, radio, but it travels even faster that way, social media. So again, I turned to Greta. Nobody knew who Greta Thunberg was 18 months ago. Now she alone occupies 30% of the social media traffic. 30% of the social media traffic mention her one way or another on a daily basis. So we have to rely more and more on non-traditional educational methods. And they're risky because they're quick and because they're short. They run the risk of being incomplete or downright wrong, but they also have the impact of immediacy. So students, you're all social media savvy. You know how to use all these various avenues of social media. Educate each other around the world. Educate your parents. You don't need social media for that unless you talk about dinner time conversation as social media. That's a good form of social media that even I understand. So yeah, good questions. Increase the rate of impact of education in non-traditional quick means and the biggest problem is that there are still people who refuse to accept scientific fact. That's the biggest dilemma, biggest obstacle.
Thank you for your question, France. I very much appreciate that. I wish we had time throughout all of the different sites to continue the conversation. I really do. Perhaps at some point we can convince all of this wonderful group to get back together and just have a less formal conversation. I think that could be a lot of fun. I would like to thank you all again for participating, for being here, especially Drs. Howarth and Ingraffia. If all sites could unmute for a second and say thank you, that would be wonderful. I'm very, very glad that you've been able to.
Thank you. Thank you all.
Thank you for listening to us, talking with us. It's been fun.